Hello everyone and welcome to my YouTube channel Chemistry Unfolded. Today we are going to study about the UV visible spectroscopy. So let's get started. First and foremost, the most important is the UV visible range within which we can determine the spectra. So the UV lies in the range of 200 to 400 nanometers and the visible lies between the range 400 to 800 nanometers. First up, we have the Woodward Fieser rules. These rules help you in determining the lambda max value for a given compound. For the cyclic butadiene, you have 217 nanometers. For homoannular diene, you have 253 nanometers. Homoannular diene meaning both the double bonds lie within the same ring. I will show you in the coming slides. Heteroannular diene meaning the double bonds lie in two separate rings. Then you have certain increments which you need to account for while determining the lambda max. For each alkyl substituent that you have in your conjugated system, you add plus 5 nanometers. If you got an exocyclic double bond, you add plus 5 nanometers. Now what do you mean by exocyclic double bond? Exocyclic double bond is the double bond which is outside a ring. You'll get to see in the examples which I'll be solving a little later. Then you have a double bond extending a conjugation. When I say a diene, meaning there are two double bonds. Now, from the term double bond extending conjugation, it is quite clear there must be a third double bond or a fourth double bond in conjugation. So for each such double bond, you will be adding a plus 30 nanometer. Now that was for plain systems. Now in case you have an unsaturated carbonyl compound, there are a different set of values that you got to remember. First of all, for a 6-membered, here I think there is a font error, but this is the alpha. Okay. For 6-membered alpha beta unsaturated ketones, it is 215 nanometers. And for 5-membered alpha beta unsaturated ketones, it is 202 nanometers. Again, we have the increments here. For exocyclic double bond, you have plus 5 nanometers. Double bond extending conjugation, we have plus 30 nanometers. Now coming to the alkyl ring residues, just like in the previous case, for every alkyl substituent that you have on your conjugated system, you add plus 5 system. Here also you have certain values to be added. But here the values differ depending upon the carbon. When the carbon atom is on the alpha position, it is plus 10 nanometers. Beta position, it is 12 nanometers. Gamma and gamma plus 1, it is 18 nanometers each. Now here is a question. The number of exocyclic double bonds present in the compound given below. Now as I told you earlier that the exocyclic double bond meaning the double bond outside the ring. Now if I consider this example 2, here you see the presence of an exocyclic double bond here, and this double bond is exocyclic to both the ring systems. So the number of exocyclic double bonds is 2, and you would add plus 5 to your lambda max values. Okay. Now if you consider this example, how many exocyclic double bonds do you see? Here we can see 4 exocyclic double bonds. Here is your 1, this is 2, and this is 3. Why? Because this double bond is exocyclic to this ring, as well it is exocyclic to this ring. And this is the 4th ring to which the double bond is exocyclic. So you got to see a 4 exocyclic double bonds. The exocyclic double bond meaning the double bond outside the ring as such. Okay. Next, the number of ring residues present in the given compound. To find the ring residues, you must consider first your conjugated system. So this is my conjugated system. Now I have to see the alkyl residues across the double bonds. So this is my 1. Now to this double bond, this is 1, 2. Here also I've got 1, 3. Then here is 4, and this is the 5th one. So, and here also there's 1. So you here 6. So there are total number of 6 ring residues present in this conjugated system. You need to see for the ring residues only across the conjugated system or your diene system. Now here we have to determine the lambda max values for the given compound. Okay. First, this is what type of a system? This is a heterocyclic system because the double bonds are present in 2 separate rings. So heterocyclic system, so 215 nanometer. Then exocyclic double bonds. I see the presence of just one exocyclic double bond outside this ring. So it is plus 5 nanometers. And then you have your alkyl substituent, that is here 1, here your 2, here is your third one, because this here's everybody is hydrogen and not an alkyl substituent. So you got the presence of 3 alkyl substituents, so it is 15 nanometers. So your total lambda max value is 235 nanometers. Now next, let us determine the lambda max value of this structure. Now this is a homoannular diene because we see both the double bonds in one ring itself. Okay, so this is a homoannular diene. And the value for homoannular diene is 253 nanometers. Then you got to see for the presence of exocyclic double bonds. Here we cannot see any exocyclic double bond. So it is 0 nanometers. Next, we see the presence of alkyl ring residues across the conjugated system. So for the conjugated system, we see that there is an alkyl residue here, there is another alkyl residue here. So 1, 2. In total, we have 2 alkyl ring residues. So 10. Fine. If you go to see for double bond extending conjugation also, we do not see the presence of a double bond extending conjugation. So this is all that we have in this ring. So once you add up the total, it comes to 263 nanometers, which is the lambda max value for this compound. Now let us see one example of an alpha beta unsaturated carbonyl compound. So there are 2 cases, one for 5-membered ring, the other for 6-membered ring. So you need to see that this is a 5-membered ring. So what is the value for the 5-membered alpha beta cyclic ketone system? So it is 202 nanometer. Next you will see for an exocyclic double bond, we do not see any exocyclic double bond. Also we do not see an double bond extending conjugation. So next we see is the ring residues that are present across this system. For carbonyl system, we look at the system given in this. So the substituents present are here. First is your alpha. So which is your alpha substituent? This is your alpha substituent. Next is your beta substituent. Okay. See, and here also you got another beta substituent. Okay. So you got to see the presence of one alpha substituent over here and 2 beta substituents here. This is beta, this is also beta. So that is for alpha you take as 10 nanometer, for beta you take as 12. So 2 are there, so it is 24. And upon addition you get 236 nanometers as your lambda max. Fine. Here's an example for practice. So you all can solve this example and find out the lambda max value and type it out in the comment section below. Here's another example given. So this is also very simple. Please find the lambda max value and type down in the comment section. I hope you liked the video. If you liked, please share it among your friends and subscribe to my channel.